Good afternoon. So I had the worst case of bronchitis ever over Thanksgiving, and I'm still recovering. And I always forget to drink water during my talks, so I'm deathly scared that I'm going to lose my voice midway through this one. In order to counteract that, I'm going to steal a trick from my friend Stella. Whenever I take a drink of water, like so, I want you to encourage me by clapping. Thank you. So today we're going to be talking a little bit about some techniques for organizing large Vue.js code bases. These patterns are, I'm finding them in a Vue context, but one thing I want to emphasize is that they're good for most large JavaScript code, most large front-end code bases. In this talk, we're going to be looking at both object-oriented and functional techniques for how we can get a handle on the problem that is JavaScript state management. Now, Vue.js's big claim to fame is that it's a system for reactive programming. This is a buzzword, so I'd like to unpack what it even means. So I turned to Wikipedia first for an authoritative definition, which is, of course, a great idea. When I did this, I got a bunch of stuff about data streams and the propagation of change. I got a bunch of stuff about an associated execution model that facilitates the automatic propagation of change involved with data flow. And the reason I tripped over my words there a bit is not a side effect of the bronchitis. It's that this is a very, very verbose and academic way of saying that it's just like Excel. It's programming where, when data changes, fields that observe that data also change. That's all it means. It's a pretty intuitive model for UI programming. A lot of people have paid money for Excel. And so it's no surprise that a lot of the most influential frameworks in front-end JavaScript, starting as early as Backbone, have focused primarily on making UI programming more reactive. And so again, while this talk is going to focus on ways of managing reactivity within large Vue.js applications, a lot of the fundamentals should apply no matter what framework you're using, be it React or jQuery or some 5-day-old frameworks that I don't know about yet. So let's look at some Vue. There's going to be a quick, honestly, 4 or 5 minute introduction here. And the great part about this is that Vue is simple enough that that 4 or 5 minute introduction is not just enough for you to understand what I'm going on about in my talk. It's also plenty for you to build a basic Vue application. Here's a simple Vue component template. It displays pictures of a cat in a carousel. Now, before any of you notice and start distrusting me, this code does have a bug in it. It will keep advancing photos infinitely. We're going to assume for demonstration purposes that we also have an infinite supply of cat photos. I'm sure Mandy likes that idea. We can show templated text in Vue, such as the cat's name, with mustache syntax, just like in Handlebars or Angular or many other frameworks and templating languages. We can also bind JavaScript to attributes on HTML elements within our template. We can use a object reference to get the image's source. Finally, we can bind event handlers, like the event handler that advances the photo, to events at the element level, so in this case, an individual button. And this is kind of an interesting piece of magic trick here. Vue rewrites its data objects on initialization using defined properties, so that all of them have an implicit setter method that overrides the equal sign operator. When you modify their values using the setter method, what happens isn't just that photo index gets changed. A recalculation of any computed values and any virtual DOM elements that depend on that data is also triggered. And what this means is that all you need to do here to change the photo displayed in the carousel is to increment the photo index using the assignment operator. The rest of the steps necessary for actually updating the photo that's displayed are going to happen automatically. Here's the JavaScript code that makes this component template go under the hood. Note that there is not that much of it. Most of the logic is in the template. What we need in terms of backing code is to name the component. This is not strictly necessary, but it makes debugging a lot nicer. We need to pass the cat object into it as a property. and create a data object to store the photo index. Data is roughly equivalent here to component state in React or to the scope object in Angular, if you've worked with those frameworks. And to kind of demo the other important parts of Vue, we're going to refactor a little bit to move some stuff out of the template and into the component. This is something that you don't need to do, but it's useful for demonstration here. One of Vue's cooler features is the ability to compute properties. A computed property automatically watches its dependencies and is recomputed only when one of those dependencies changes. So here we're expanding the idea of a reactive data structure that underlies Vue to include properties that are derived from that data. Here we're refactoring the current photo method from the template, the current photo displayed in the template from just a photo display there to a computed property so that we can give it a name. Can I just flip that off the screen again? Vue also lets us declare methods on a component. The important difference between methods and computed properties is that computed properties watch their dependency trees and methods just execute. Computed properties aren't appropriate for anything that has side effects because they're not being triggered predictably. And methods are appropriate for things that have side effects like changing state or updating the server, but that don't change data in a way where you directly want it to be tracked by Vue's reactivity system. The really cool thing about Vue is that any state changes that go on in a method that are part of this tracked reactivity system will get propagated automatically. But again, in Vue methods, you're going to want to make sure that the only visual changes are going through that tracked reactivity system rather than being expressed in the method directly. Now, one thing you may have been thinking as you looked at this demo is that this sounded suspiciously like two-way data binding. Guess what? It is. And I know I've lost about half of you this video. And so I'm going to go on a brief rant. Two-way data binding is not actually evil. It is popular to think it is. And this is because we've never really recovered from our feelings as a community about early Angular and early Ember and all these other earlier frameworks, that because we didn't know how to use two-way data binding properly yet, one, had really bad affordances for using it effectively, and two, let us think we could just use it willy-nilly even in places where it wasn't appropriate. We got caught in a lot of traps, and so we kind of threw it away as a community. I don't think that's a good idea. Two-way data binding, when used judiciously, is really intuitive. Just think back to that really simple and easy to understand template that I flashed on the screen at the beginning of my talk. I think it's short-sighted to abandon the technique entirely, now that we do know a little bit more about where it breaks down and where it can get you into trouble. Now, where it can get you into trouble, there are two big issues. One, it doesn't provide a neat place inherently to modify data as it's displayed or updated. If, for example, you're displaying a dollar value on the screen, you're going to wind up converting back and forth a lot between the numerical representation and the representation with a dollar sign in front of it that's displayed to the user. This is petty, it's annoying, but it's not a big deal. What is a big deal is that since two-way data binding can ricochet across an app really fast, you wind up getting issues where you change one thing in one place and then you go, well, why is that thing changing over here? How? Or worse, this thing just changed. How? And so as a community, again, we kind of settled on the idea that Flux-style state managers, where we have a big global state that can only be changed in certain ways, were the things that could correct this issue. These can work really well for helping us out of this trap, but they're not a panacea. You need to use them thoughtfully. Logging state changes to the console only helps you trace where those state changes came from if you've also named those state changes well. And so this is kind of a cry against contempt culture, ultimately. Both two-way data binding and global state management are big hammers. We don't solve complicated bugs with big hammers. We solve complicated bugs with teamwork and by not being judgmental about people's technical choices. Okay, rant over. What can you take away from this? For effective two-way data binding, you need to have a scheme for inserting additional functionality for that $sign bit. You also need a strategy for mitigating its very real observability flaws. This can be something like really specific custom event names. This can be using two-day data binding in conjunction with a global state manager like Flux or Redux. They're not actually incompatible. Out of the box, Vue gives us Vuex for this. Vuex is a global state manager a la Flux or Redux, but it's a global state manager that also aggressively leverages Vue's reactivity system. Let's explore how we can use it in a way that complements Vue's use of two-way data binding. And for this, because I used to live on a goat farm, we're going to talk about a goat. A goat named Buster. Let's start by building a basic Vuex store around Buster. We give it an initial application state. In this, we name our goat, and we account for how playful he is, not that very, and how destructive he is. Yeah, he's pretty destructive. These are the most important properties of goats. As Mandy mentioned, I used to live on a goat farm, I know. Mutations, like Redux or Flux actions, are how we change things about our goat. They provide a constrained set of paths for mutating data. So if you wanted to change Buster's name to "you jerk," we would use mutation to do so. And this would be a place to also insert observability logic using a Vuex plugin. And so we're setting up this big reactive data structure, kind of like an in-memory database with a constrained set of paths for mutating its data. Again, a very common JavaScript pattern. And in a Vue context, let's look at how that works when you try to actually use the data. Our goal here is to write backing JavaScript code for a Vue template that looks like this. It looks like a normal two-way data binding-driven Vue template, in which we output a name and can set a name with an input event. But we also want it to be able to hook into the Vuex store that we've constructed and all of its nice guide rails for making two-way data binding less bad. Getting the name in the template is pretty easy. We can just use a good old computed property and reference the state directly. But we don't just need to get the name here. We need to set it as well. For this, we can use computed getter setters, an incredibly cool feature that I only learned about when I stopped trying to write Vue like JSX for React. By default, computed properties only consist of a getter. But we can also define them as getter-setter pairs. This lets us leverage object-oriented principles around encapsulation and information hiding. Our templates don't need to care about the fact that we're referencing the Vuex store underneath. They just need to care that they can get and set the goat's name. But we're still getting the power of a state manager because the component knows that we're using the state manager to get and set this name. This provides a really powerful way of thinking about container components if you're moving to Vue from React Landia. You can have child components push data up into the container and maintain their own encapsulation boundaries, rather than pushing handlers down into the children and getting that awkward thing where you've got 10 layers of pushing that handler down into the children. This is great for some kinds of complexity, namely those that are driven by complicated widgets and complicated kinds of inputs. But what about complications in the data model itself? For these, we need to turn to a new feature, calculating the cuteness score of a goat. Now here's an algorithm for calculating the cuteness of a goat based on how playful it is and how destructive it isn't. I have gotten criticism from friends who think this is a terrible algorithm, but these friends did not used to live on a goat farm, and they still think that cute goats can be destructive. No, no. This is a very practical measure of cuteness. It's a very practical measure of cuteness that's easy enough to plug into a computed property on a Vue component. If you've got only one component that deals with goat cuteness. It's easy enough to have that component reference a particular goat in the store. But again, we're still assuming that this component, and only this component, is referencing a particular goat's cuteness. When we suddenly need to think about cuteness in a multi-component way, we need to extract the goat cuteness algorithm to utility function. which is where it gets a little more awkward. Maybe we can put it in a different file, but it's still kind of hanging out there. If we want to keep all the goat-related things in one place and only one place, we can also use getters on the Vuex store. Getters are like computed properties for the store as a whole. They're in fact implemented as computed properties under the hood. But this doesn't erase the awkwardness problem. Getters have to talk about the entire store, and they specifically can't return functions. So we can't efficiently compute the cutenesses of individual goats. If we want to compute cuteness in a store getter, we need to compute the cuteness of all the goats, which produces a data structure that looks kind of like this, and then reference individual goat cutenesses. This is super non-intuitive to read, and it also gets rid of the precise targeting that's so nice about Vue's reactive data structure, since we suddenly need to recalculate all the goats if any goat changes. So let's dive a little deeper to kind of figure out our way out of this problem. Here's the dependency tree of the cuteness of any individual goat. This is from the component that we were looking at earlier that just talked about goat cuteness in this narrow, focused way. You need to know what goat it is to compute the cuteness of an individual goat. You need to know how playful that goat is, and we need to know how destructive it is. When we moved to the getter-based approach, the dependency tree started to look a little bit like this. How does the dependency tree look when we are doing the utility function approach? Looks a little bit like this. It's a little more twinned. We combine the key with playfulness and destructiveness individually, and then use those to derive cuteness. This technically has a few more pieces, but each of the pieces is a bit more understandable. We're optimizing here for humans rather than for math. If we want to formalize this, but not go full-on object-oriented, we can use a functional programming concept called partial application. Here's partial application in its simplest form. You make a function that binds a specific argument to one of the arguments of another function. If you wanted to make a partial apply function, it might look kind of like this. But while this can be a convenient shortcut, you don't actually need to do that. You don't need to go to all that ceremony. You just need to make a function that adds 3 to y instead of adding any arbitrary x to y. And what we want to do here is kind of a spin on partial application. We want to be able to take the name of the component property and apply the function to the property's computed value. You want to make a component apply function that applies cuteness to goat and returns a computed property function. This sounds complex. It's not. It's really just one line of code. We open a new closure, we grab a value from the Vue component object using the supplied key, and then we feed the argument to the supplied function. And now we've got this lovely little function that lets us stay in our happy functional world, but be a little bit less verbose. There's a little less boilerplate. We can also go even more pure functional programming about it and apply this function not to a property on the component, but to a key path against the store directly. This is a more complex function. I'm going to kind of skip past it. Ask me after if you're interested. And then this is the template we wind up with when we use this approach. This works. This isn't awful, but this isn't awful. It works. But I find it kind of irritating. On line 3, we've got goat.name. But on line 4, we've got just cuteness, even though cuteness is also a property of goats. It's a little misleading. At this scale, at this single component scale, my irritation is mostly about aesthetics. At larger scales, though, this becomes actually a problem. This becomes an issue with poor data encapsulation, making reactive data structures harder to deal with. The reason this is true is that if I see goat.cuteness, I can be pretty sure that cuteness is a property of goats, no matter how large and weird the code base is, no matter how weirded out I am by the fact that change suddenly happened in my UI that I don't know where it came from. And because of that, I know to look at the goat-related code when things go weird. If the cuteness method is just kind of hanging out in thin air like this, I don't have that hint, and so I don't have nearly as good an idea of where I could start. This, of course, is why we invented object orientation in the first place. And the classic way of doing an object-oriented architecture and model view controller architecture in JavaScript is going to be to make a goat model. I have not drunk any water yet. A goat model, an object that describes the behavior of a particular goat. But when we try to plug this into Vue, we start running into problems. Since we're using an entirely different initialization strategy for our data objects than Vue expects, we lose the reactivity guarantees that we can get with normal Vue. We're encapsulating logic, but we're doing so at the expense of actually leveraging Vue as a framework, so this is not a good idea. I was frustrated by this problem for a really long time because it didn't make sense to me that a framework that used object-oriented patterns so effectively elsewhere would make this really common pattern for object-oriented user interfaces not like a thing. I figured there had to be a way. And so I did something that ordinarily I would not recommend because I was so frustrated. I started source diving in Vuex. I figured that if Vuex, which is an official Vue library, could make its data tree reactive in a way that the maintainers approved of, then maybe there were some advanced techniques that were really clever that I could steal. Really clever is never a good idea, but I was frustrated. But then the answer turned out to be ridiculously simple, so I'm glad I did go source diving, and even if my motives were not particularly great. It turns out that Vuex just makes a big old Vue component under the hood. It doesn't have a template, it's not mounted on the DOM anywhere, but it's still a component object. It still has a baked-in reactivity tree. And so it's just, Vuex is just stealing the same reactivity tree structure that powers the rest of Vue. We're not using any private APIs, and so this is safe to deploy to production in the confidence that when Vue updates itself in 6 months, you're not going to need to suddenly change your entire code base because you did something funky. The only thing fancy about this technique is learning to look at Vue kind of sideways so that we can realize that we're allowed to use components like this rather than just for printing things to the screen. And so now we can rewrite our goat class as a template-free, unmounted component, with cuteness as a computed property of a goat based on its playfulness and destructiveness. Then we can use it like we'd use any other fully reactive piece of data. And we can get to treat a goat's cuteness as just another property of a goat. But we're abandoning Vuex with this strategy, which makes me super sad because I like logging all of my implementations to the console. I like being able to inspect the global state. I like the debuggability that gives me. Now, often we frame object-oriented versus functional approaches as this very oppositional thing, like they can't possibly coexist. I think that that's really sad. I think that both approaches offer useful lenses, and so I think it's really awesome that JavaScript as a language and as a community is a powerful and multi-paradigm language. I think it's really awesome that JavaScript can accommodate them both. So to figure out how we can actually accommodate them both in this particular case, let's look at these dependency trees again. If you're looking at this through a functional lens, where the data structure is the thing that matters most, we're looking at a goat like this as an agglomeration of its playfulness and its destructiveness. And so all we need to do to shift to looking at a goat as an object, as something, as cuteness as a property, as a first-class property of goat, rather than something that's just kind of hanging out, is to look at a goat like this instead. We're expanding the clump of data within the reactive data tree that we're looking at. They're much less different than a lot of the hype would let you think. And so we can combine the Vuex approach we were looking at earlier really nicely with the model approach we just looked at by just having our models reference Vuex instead of maintaining their own state. Here's a quick gotcha when you're doing this. You need to pass the story in specifically when you initialize anything. Since we're kind of bypassing the normal Vue component initialization process, we can't count on it to automatically initialize, so that's why we need to explicitly telegraph the store. We can also even use the partial application technique from earlier to make the entire thing less verbose. The thing I like about this approach is that it gives me the best of both worlds. It's a little boilerplatey, and so I do want to stress that for simple Vue apps, you don't need to go to all this trouble. I scared a lot of people when I didn't give this caveat, so you're getting this caveat now. But as your applications grow more complex, you can use techniques like this to get the observability and traceability of a global state manager and the easy code sharing and understandability with an object-oriented approach. I think that's pretty cool. I want to pass some grand thoughts to end this on, but mostly the grand thought behind this talk is that we shouldn't feel obligations to purity of technique. The thing I fell in love with in Vue is that while it has scaffolding and opinions if you just want to code, it is totally willing to get out of your way if you disagree with one of those opinions. That it embraces the idea that we're here to make useful software, not have arguments about whether something is properly functional or properly object-oriented. I feel like that's a pretty framework-agnostic grand thought. I'm Betsy. You can find me on the internet at Betsy the Muffin on Twitter. You can find my company at wecohere.com. You can hire me for apprenticeship programs or Vue conversions or really many other things by talking to me after or emailing me at betsy@wecohere.com. Thank you.